Alright, for some reason this morning when I was recording these videos, the sound did not record. So I'm going to go back through here and kind of explain what I was doing. I'm not going to redo all the work, so I'm just going to talk over what I did here. So in number 6, the trick here was seeing that you could write 1/5 and 125 as powers of the same number, so they're both able to be written as powers of 5. So 1/5, same thing as 5 to the negative 1. 125, same thing as 5 to the third. From there, it's just a matter of simplifying. Remember that when you've got power to a power, you multiply. And then from there, once we've got the same base on both sides, what has to be true is that exponents are equal. So I set them equal to each other and solve for x. Now number 7, after we subtract 7 from both sides, we may think that it's possible to write both sides as powers of the same number, but you simply cannot. 5 and 8 don't share any bases, so we have to try something else. And what we have to do is take the log of both sides. The reason why we take the log of both sides here is because one of the properties of logarithms, the most useful property of logarithms, is the one that says when you've got an exponent. I love how the music gets louder. So when you've got an exponent inside of a logarithm, what you're allowed to do is move that exponent out in front. That helps us here because when our exponent is our x, the thing we're trying to solve for. So once we get that x out front, we've got x times log of 5. All we've got to do to finish solving for x there is divide by log of 5. Alright, in number 8, biggest thing there is just understanding that the total cost was the $300 and the $12.99 per phone line. So each person carries with him $12.99 charge. After that, all we gotta do is divide by the total number of people, x. And then in number 9, all we really had to do here is just figure out what the common difference was. Once we figure out the common difference, it's just a matter of plugging those numbers into the arithmetic formula. So first number 17, common difference is negative 12. Just plug those two things in and simplify. Number 10, kind of similar, but it's not an arithmetic sequence, it's a geometric sequence. Each term is being multiplied by 10. So once I figure out that the common ratio is 10, I already know what the first term is, so it's just a matter of plugging in the first term, plugging in the common ratio. And in this problem, I was trying to find the 12th term, so I'm plugging in 12 for n. Next problem, basically we've got a sequence that starts off at $40, then the second week it goes to $75, and we were told that if the pattern continues, what's the amount given away in the 7th week? So if the pattern continues, so aka it's just going up by $35 each week, if that pattern continues, the 7th week we end up with $250. So I solved that using the arithmetic formula. You could just as easily, solve that by hand. It's just 7 terms, so 110, 145. You could do that until you get to the 7th week. But obviously, if it was something like 100 terms, you wouldn't want to waste your time doing it by hand. Number 12. So number 12, basically we're trying to figure out like what shape is formed by these four lines. So these are four linear equations, and we want to figure out what shape is formed by those four lines. So to do that, I need to figure out what these slopes are. If I can figure out what the slopes are, that's pretty much just going to be able to let me narrow down what kind of shape it is. So what I've done is solved each of these equations for y. So I got y by itself. So the reason why I want to get y by itself is so I can easily determine the slope. So remember, when y is by itself, the slope is just the number in front of x. So for the first one, the slope is just -3. For the second one, the slope is 1/3. So what we've found is that we've got two pair of sides with the same slope. Two sides have a slope of -3. The other two sides have a slope of 1/3. So we've got a pair of parallel sides and a pair of parallel sides. And also, since the product of those slopes, 3 and -1/3, since their product is -1, that also tells us that we've got perpendicular sides. So these lines meet at right angles. So putting all of that together, we've got opposite sides being parallel, and we've got sides that intersect at right angles. That is exactly what a rectangle is. Opposite sides parallel, four right angles. That's what a rectangle is. Alright, where are we at? 13. Not a lot to say about 13. Just imagine in your head a globe, some kind of sphere, and you slice right through the middle. What shape is that slice? Well, that slice is going to be a circle. That's what a cross section is. It's just a slice. It's the easiest way I know to put it. Alright, number 14, that was the population density problem. So we were told that the shape of this town could be modeled by a rectangle, approximately by a rectangle, with dimensions 6 miles by 7.5 miles. So first thing I had to do in this problem was figure out the area. So if it's a rectangle, all we've got to do is multiply the length and the width together. So 6 times 7.5, well, that's 45. So the area of this town is 45 square miles. Once I know that, finding the population density is pretty easy. All I've got to do is take the population and divide it by the area. So if there's 14,850 people, divide that by the area, and that reduces to 330. So population density is 330 people per square mile. For number 15, it's a pretty simple, like, right triangle trig problem. We got a right triangle. Anytime we've got a right triangle, that's when these trig functions apply. So in this one, we were given the 34-degree angle, and we were given the adjacent side and the hypotenuse side. That is exactly cosine. So that's how I know to use cosine here, because that's the combination of sides I was given, adjacent and hypotenuse. So setting that up, we've got cosine of 34 degrees equals x over 17. Solve that for x by multiplying both sides by 17, making sure you're in degree mode, and we get x is about 14.1. And number 16 was a special right triangle, a 45-45 triangle. The thing you got to know there is that the two legs are congruent. So if this one's 3, that one's 3 too. The other fact about 45-45 triangles is that the hypotenuse is always this length, so the length of the leg times square root of 2. So if this one's 3, that's 3 square root of 2. So in the original video, I went a little bit overboard here just to kind of drill Yeah, drill down the point. You know, if these are all 45-45 triangles, and we know the legs, the hypotenuse is always whatever the leg is times square root of 2. That's the pattern. You know, that's the rule. All right, and then number 17. We were asked to find cosine of theta. So the definition of cosine is the adjacent over hypotenuse. And we were given cosecant. We were told cosecant of theta is 13 over 5. So I put the definition of cosecant right beside it here. Hypotenuse over opposite. It's the reciprocal of sine. So the reason why I put the definition here is just so you can see that we don't yet have enough information to find cosine. Notice what I need to find cosine. I need to know the adjacent side and the hypotenuse side. I only know one of those. I know the hypotenuse side. So I've got to find that third side in order to finish finding the cosine. So to do that, you know, since it is a right triangle, I'm just going to use Pythagorean theorem here. So 5 squared plus x squared equals 13 squared. So solve it for the other side. That other side has to be the adjacent side. So once I know that, just plug that in. 12 over the hypotenuse. We already knew the hypotenuse. It was 13. So cosine of theta is 12 over 13.